In today's video, we'll talk about an IDE that can make your work with .NET projects much easier. Rider from JetBrains. Rider is currently available for free for non-commercial use, for learning and open source projects. It's a perfect option if you're just starting your programming adventure, developing your hobby projects, or want to test something new at no extra cost. I'll show you the main features of Rider that make this environment friendly to new users. We'll go through the interface, features that support coding, debugging, integration with GitHub, and many other useful tools. If you're new to the channel, make sure to subscribe to stay updated with new content. For those who have been using Visual Studio until now, there is also the option to import profiles that will allow you to use similar keyboard shortcuts that you previously used in Visual Studio, now directly in Rider. Upon launching Rider, we will see a view similar to this. This is where the list of all the projects we previously worked on in Rider will be visible. In this view, we also have the option to open a new solution or open a folder from the local disk, or cloning a repository from GitLab, of course after logging into one of these two services. Maybe I will simply use the new solution option as a demonstration, and we will create a new console application from scratch. As we can see in this view, primarily on the left side, we have the option to select the type of project, which includes console, class library, desktop, web, services, and unit tests. And furthermore, we also have additional options depending on the extensions we have installed in our Rider. And of course, here depending on the type of project, for example, for a web type, we also have additional parameters regarding which specific template we would like to use when creating such a project. So, for example, for the web category, we have, as you can see, a Blazor application, Web API, an MVC application, or Razor Pages. And of course, depending on the choice of one of these options, the created project will be suitable for our needs. And maybe as part of the demonstration, I will simply use the console option, and it is here that we will first provide the name of our solution. So let's call it Writer Demo. For the project name, I will simply use writerdemo.console. Below, we can also specify in which directory on our disk this solution will be created. I might leave this default option here. Besides, I also have the option to check Put Solution and Project into the same directory. This will make our solution and project be in the same folder. However, since it's better to keep projects in separate, dedicated folders, I will simply not select that option. Below, a new Git repository will be created by default for this solution, so I might leave this option. And further down, we have the option to choose the target framework based on the SDKs that are installed on our local machine. So, as we can see here, we could change the .NET version depending on the needs of our project. Furthermore, in addition to the .NET SDK itself, we can also choose the language. Additionally, for console applications, we also have the option to set Do not use top-lower statements. Of course, selecting this option would simply mean that our application, it would have a defined class name program, and within it, a static method main that would run this console application. Maybe I'll just skip this option and press the Create button. As we can see after a moment, our new solution has been created and opened directly in Rider. So now in Rider, on the left side, we actually have different tabs. The first and main one is the tab called Explorer, which will be able to show us the solution files, or simply the files that are on our disk, depending on the view option, whether it will be File System or Solution. We will see either all files related to the solution or all files located in the main directory of our open project. On the other hand, below, in this side context, we actually have other tabs that will correspond, for example, to the currently made changes, in terms of Git's repository management, or some extensions, such as Azure Explorer. Another example would be a tab that shows us the tests detected in the solution, the logs, that will be output during the solution build, or even a tab that helps us install NuGet packages. Maybe later, in this material, we will move on to the most useful tabs in the context of developing applications. So now let's just see how we would be able to add new directories and new files to our solution. For example, to first add a directory to the console.lab project, I just need to right-click on it, then go to the Add tab, and it is here that I will choose the directory option. Maybe we will name this folder Models. If I now want to create a file with a person class in this newly created folder, I just need to right-click on the folder, then select Add, and choose the class.interface option. As we can see in this window, we also have the option to select a template. for the new file. So here I would be able to say that it will be a class, an interface, a record, a structure, or a value of the enum type. Maybe I'll just stick with the class option and name this file as person this way. As we can see when adding the first file to our repository, we also receive additional information from Rider asking if we really want to add this file to the repository. I will of course check the Don't Ask Again option and click the Add button so that this file is included in the changes we are making. In terms of the Git repository, so as we can see now, I have two files open and created person and program. If we close them, it will be enough to double-click on a specific file with the left mouse button, and it will open in our main editor window. However, if I wanted to open the project file, which is a file with the CS-Proj extension, as we can see here, by double-clicking on our console application, unfortunately, this file will not be opened. To open it, we have two options. The first is to right-click on it, then select Edit, and edit this file. As we can see, it has now been opened, and we can now preview the details of this project. The second, perhaps even easier option, is simply to drag the name of the file and drop it anywhere within the editor window, which will also cause the file to be opened and editable. Thus, in this way, we are able to add new folders, new files, and open them in the Rider editor window. Let's see now how to add a new project to an existing solution. And later, we will see how to add references between two projects that are part of the same solution. To do this, in order to add a new project, I just need to right-click on our main solution, which is Rider Demo, then select Add, and choose the option New Project, or while in this context, I can press the key combination Ctrl-Shift-N. As we can see after a moment, we already have a familiar view where we can first select the type of project, and depending on the specific type, we will also be able to choose specific templates that we saw earlier. Maybe this time I will select the class library option, and we will name this project accordingly, Rider Demo.class library. This will also be a project in .NET 8. So, after pressing the Create button, as we can see, shortly here on the left side, in our solution window, we actually have two separate projects. This is the existing console application and a class library project that has just been recreated within this very solution. However, by default, if I wanted to refer, for example, from our console program to a class that exists in this class library project, then these projects, they have no connection, and therefore, I would not be able to refer to any type between these two projects. So, to add such a reference, you just need to right-click on the Dependencies option, then Reference, and it is here that I can select the project that is visible within the same solution opened in Rider. I will now choose the Class Library Project option, and after pressing the Add button, if I were to look again, the console project, as we can see, already has a reference directly saved in the .ces-proj file, which points to a reference to the class library project. Thus, in this way, our projects within a single instruction can refer to other projects, but another type of dependency that we can add is simply to external sources available, for example, on NuGet. So if I wanted to add a NuGet package to our console application, we can actually do this in several ways. One of them would be to go to the NuGet tab, and it is here that we can primarily search for NuGet sources. We can also check the pre-release option, which will show us packages from non-production versions. And furthermore, we can filter everything using this simple input. So, for example, if I type the name of the entity here, we can see that we actually have a whole list of packages that have been matched based on the name of the given package and automatically sorted by the number of downloads of that package in NuGet. Next, by selecting a specific package, if you would like to install it to our project, we can either install it all at once, meaning for all projects immediately, or by choosing the plus option. On a specific project, we can install, for example, the Entity Framework core package for the console application in the version we need, and after pressing the Install button, as we can see here, we also have information that our console application now has a dependency on the Microsoft Entity Framework core package of this specific version. So, we can find this information both in the project file and now here in this NuGet tab, where we have information about the installed packages in our solution. Of course, now being in the context of this specific package that has been installed in our solution, we can either uninstall it from the project where it was installed or add it to the other projects within our solution by clicking the appropriate buttons with the trash can icon or the plus sign. Thus, In this more visual way, we can filter, install, and change the version, or even remove NuGet packages from our solution. On the other hand, the second way would be to use the terminal tab. All we need to do is navigate to the directory, for example, the console application, and if I wanted to install a NuGet package, I can do this using the .NET CLI add package. Let's say I would like to install the Newton South JSON package, and after executing such a command, this package would be added to our console application shortly. Let's go ahead and see how we would be able to run the project we are working on in Radar. To do this, we can either use the option available in the top menu, where we primarily have the ability to select the project we want to run. So, since we currently have only one project that we can run, it is the only one that appears in this context. So by clicking the play button or pressing the shortcut Ctrl F5, after a moment within Radar, this program will be executed. And as we can see, we now have the Run tab open, specifically showing the result from the console application riderdemon.consolab. Currently, it simply outputs Hello World. Of course, if I were to change the content of this program, for example, by adding Hello from Radar here, then upon restarting, this program will be executed again, and this time the console will display information about the two console log statements that were appropriately printed from our program file. And what if we had more than one project in our solution that we want to run in parallel? For example, for a microservices application, there may be a need to run several web API projects simultaneously. So let's add another console project to our solution, appropriately selecting project type as console. We can name this project Rider Demo Console App 2, and after pressing the Create button, we can see that this new project has been added to our solution in Radar. So now, if we look again at this drop-down for running a specific application, we can see that we already have two options here. The console application that was there before, and console application 2. By appropriately clicking the play button on the given option, as we can now see in our run window, the project console.lab has been launched. Also, returning to the question of how we can run two programs simultaneously, it really is enough. We will right-click on any project, then select the option Run Multiple Projects, and it is now that we can first select which projects we want to run simultaneously. By pressing the OK button, we actually have one more window where we can primarily choose the Run option, and it is here that we can specify that a certain project must be run after another project, or immediately without the need to set dependencies between projects. Furthermore, here we also have the option to select Do Not Debug, which would allow us to disable the debugger at the level of a specific project. However, for now, if I want to run these two applications, I will just press the OK button. And as we see, after a moment, now in our Launch Options window, we have one more option, specifically Multi-Launch. So now, after selecting this option, if I restart the project, as you might guess, we actually have two projects that have been launched simultaneously, and we can switch between these two tabs to check the results from both the console application we just added and the application where we previously made a small change. Let's move on to the editor and see what features Rider offers that will help us create or develop existing projects. Perhaps the first function we will look at is Code Complete. If you previously used Visual Studio, the equivalent of this function would simply be IntelliSense. So as we can see here, for now in gray, Rider is trying to suggest a new line of code, which we can either accept or appropriately ignore if that line of code is not what we expect in a specific context. Currently, even though we only have two lines of code in this simple program, Rider suggests adding another console, WriteLine, this time with Hello from Rider World. Depending on the adoption of the key that we have configured and set up to accept this suggestion, in my case by clicking the tab button, as we can see, all this console WriteLine will be added to my program file. So, for example, if I wanted to create a list variable of type string named names, as we see by writing such a piece of code, Rider will automatically suggest that I initialize this variable or a new list specifically for the string type. By also clicking the tab button, as we can see, I accepted the suggestion proposed by Radar. Let's try to add some values to this list now. As we can see, Radar automatically suggested adding the value John. However, if I wanted to add let's say a variable named Alice, then while typing, Radar will suggest options, whether they are keywords or variable names that we can use in that context. Now, if I wanted to add the value Alice to this variable names, I would obviously want to use the first option. However, instead of clicking the tab button, which would accept the entire suggested line, I just need to type the name of our variable and then press enter instead of the tab button. As we can see, I still have a suggestion that is not satisfactory for us, so I will just start writing the add method call, and once again, instead of pressing tab, I will press enter again, and only now, I will add the value that interests me, which is Alice. If Writer is just now suggesting the correct value, to me, I can accept it by pressing the button. I might add 2 more variables. Let them be Bob and Charlie. For example, if I define a variable named first element, as we can see here, this code completion will be intelligent enough to suggest that I actually expect an element with an index equal to 0. Furthermore, if I define a variable named last element, as we can see this time, Writer suggests that I reference the element based on the length of list names and the index decreased by 1 to obtain the last element. Thus, depending on the context we currently have in our program, Writer will suggest different completions, and of course, we can accept or ignore them by pressing the tab or enter key, respectively. Another helpful feature in Writer is the colloquial lightbulb, which is simply the action context, which is also available in the context of either a specific line or even a particular expression in our code. For example, here, with the cursor on the index names, if we click on this light bulb, as we can see, it suggests using the index from the end of the expression. And after selecting this option, we now actually have new syntax available. Another example would be using context actions either with the keyboard shortcut Alt-Enter or Ctrl-, if you have imported a profile from Visual Studio to replace strongly typed variables with the var keyword. As we can see, after such a change, this string type has been automatically replaced with the var keyword. On the other hand, above, where we previously initialized the variable names as a new list for the string type and only later added 3 elements to it, in this context, Writer actually has several suggestions. In this case, we can use, let's say, the collection expressions option. As we can see, our list still contains 3 elements: Alice, Bob, and Charlie. Moreover, every time we invoke context actions, we also have the option to perform that action in the context of a file, in the context of a project, or in the context of the entire solution. So then, when choosing one of these 3 options, we will not operate only in that one specific place, but either in the entire file, or in the whole project, or across the entire solution. As part of the demonstration, in a separate file, I might have a variable drink test with the value hello world. If I perform the useVar action on it with the option everywhere in solution, as we can see shortly after, not only does this variable use the var keyword in the console, lab2 project, but moreover, the same change occurred to our variables in another project in the same solution. Thus, by using context actions, we can very quickly and conveniently make simple changes that will standardize our code across the entire solution. Another function that is definitely worth getting to know is commenting and uncommenting pieces of code. So of course, we can do this manually by adding a comment to a given line. Or if we are using a profile from Visual Studio, the keyboard shortcut Ctrl-KC will still be used to comment out a piece of code, while the keyboard shortcut Ctrl-KU will uncomment that piece of code. In Writer, the keyboard shortcut that either adds a comment or removes it from a specific line of code is Ctrl-Alt/. As we see, depending on the range of the selected code, it can actually be more than one line that will either be commented or uncommented depending on its current state. Another very simple but interesting feature is the code formatting function. For example, let's say I have some unnecessary white spaces in this file. I can of course format them manually, but I can also use Writer for this purpose, specifically with the keyboard shortcut Ctrl-Alt and Enter. As we see after a moment, all that excessive white space has been automatically cleaned up. We once again have more consistent code in our editor. One more feature, before we move on to debugging, is snippets, which are predefined text templates that can generate specific pieces of code and allow for very simple editing. So, for example, if I wanted to add a property here in our person class, I can of course do it myself. To define a string property named firstName with a public getter and setter, instead of manually defining such a property, I can use a snippet by simply typing the shortcut prop. And then pressing the tab key. As we see, the entire line of code is automatically inserted. And it is precisely now that I can change the type of our variable in the context of this snippet. Then, by pressing the tab key, I will be able to accept it, and after pressing the tab key again, I will automatically move to rename this variable, and it will simply be last name, in this way. So every time I define a public property in a given class, I can use this snippet. And if I wanted this property to have a private setter, I can of course use the snippet called prop.g this time. As we see here, by clicking tab, we have the ability to define the type and name of the property, which will have a private setter this time. Another very useful snippet in the context of class definitions is the snippet named keter. As one might guess, this snippet will generate an empty constructor for the given class. If I wanted to generate a constructor that initializes all fields or properties within a given class, instead of a simple ctor, I can use the CTRP option. As we see this time, we have a constructor that defines 3 parameters: first name, last name, and a variable named I. Then, in the body of this constructor, these properties will be assigned based on the parameters of the constructor of the given type. Another snippet that is definitely worth getting to know is the snippet for loops. So here we have either the forage snippet, which allows us to define a forage loop that we can appropriately control over a collection. I will give it to the collection names, after which by clicking the tab button, we can go to the type definition. The element that we will iterate over in this loop, by default, it is var, but the writer also detects that it is a collection of type string. So we can either define a specific type or stick with the var keyword. And by pressing the tab key again, we now have the option to rename the variable we will iterate over in the forage loop. This way, we can easily create new loops. Of course, we also have the option to define a simple for loop, which will by default create the variable I, after which we will iterate, as well as the termination condition. And furthermore, the incremental step after each loop iteration. As we can see in this empty loop, writer is able to detect that this loop is actually useless, as no code will be executed within it. As a result, the entire loop is now highlighted in gray. Additionally, here on the right side, we have several markers that can show us the location in the code, in which we either have a compilation error, a warning, or possible hints, suggesting what changes we can make to our code. Currently, all of them are at the warning level, so everything is highlighted in yellow. On the other hand, if I wanted to, for example, by introducing a compilation error, as we can see, one of these markers is now glowing red. Moreover, at the very top, we have an indication of how many issues we have overall in terms of errors and how many in terms of warnings throughout the open file. We can also filter everything based on the type of suggestion, warning, or error, and for example, with the errors option selected, as we can see, all the warnings or suggestions we had earlier have disappeared and are no longer available in the editor's sidebar. By appropriately adjusting the level of information we want to have visible in this window, we will decrease or increase the range of suggestions or corrections from writer. Now let's move on to discussing the debugger. So instead of that code, I will paste here a very simple program that will just print a few console.logs to the user, will also ask for their input, and will call the method foo, where we have a very simple condition checking the value provided by the user. Also, above all, to stop the program execution during debugging, we need to set a breakpoint at a specific location. All I need to do is click the left mouse button on a specific line in the code, and as we can see, after a moment, we already have a breakpoint set here. So now I just need to run this application, which is the writerdemo.console app, and then select the option with the debugger, either the keyboard shortcut RDF5 or the button with the bug to debug this application. As we can see, after a moment we have a new window here, and the execution of our program has stopped at the 5th line, where we define the variable test. So, as we can see on the left side in the debugger, this yellow arrow will indicate the place where we currently are. If I wanted to move forward, we actually have several options for that. We can simply step to the next line in our current context, which is the function being executed, by clicking the F10 button. As we can see now, our execution is already at the 7th line, and after it is executed, our program is waiting for input from the user. Therefore, to provide such input, we need to go to the console tab. And this is where to enter any phrase, let it be, for example, the value hello. As we can see from this interaction, our program has already moved on to line number 8. During debugging, we actually have several additional views, primarily including the output of our program, the ability to inspect variables and threads, additional output from the debugger, and several extra modules that will be more useful for profiling a given program. However, let's take a moment to look at the Threads and Variables tab, because it is here that we also have the additional ability to evaluate a specific expression, and moreover, we can also write down variables available in a specific context. For example, if I print the value test here, as we can see, this simple console returns the value to me, which is the value A. But here, I could just as well assign a new value to the input. Let this be a test. As we see after a moment, now in the context of this debugging, this input variable has changed its value to test, and previously it might have been assigned the value hello. Thus, in this way, if the need arose, we would be able to modify variables in the specific context of the debugger window to check how the program behaves in different cases. Okay, so maybe going back to navigating through the debugging process, by clicking the F10 button, as we remember, we go to the line that is next in a specific debugging context, specifically in the context of a given function. So here, as we can see in the console, we have printed two values, foo1 and foo2, which means the entire foo method has already been executed. If, however, I wanted to debug this method precisely, I actually have two options. I could either leave a breakpoint at the very beginning of this method, and now even if I go back by simply dragging that yellow arrow up, during the debugging session, this time even by clicking the F10 button, the program will still stop at that very breakpoint. Thus, every time we have a breakpoint, our application will stop, regardless of which keyboard shortcut we are using. On the other hand, the second option to access the FU method, this time without setting an additional breakpoint, will simply be to use the step into option. And in our case, this is not true. Of course, this console.write line will not be executed. Thus, the debugger will move to the next line of code. Therefore, once again, by pressing F11, we will be able to step directly into the method that is being executed in the current debug window. However, if I wanted to exit this method, immediately, instead of stepping through it to the end with the F10 key, I can use the step out option, which is available with the Shift and F11 key combination. As we see after a moment, we automatically move from the place where we were to the method that initially called this function. So, to summarize, to step through line by line without entering a specific method, we will use the step over option, which is the F10 key. To access the specific implementation of the method at that moment, we will use the step into option, which is the F11 key. To immediately exit a nested method, we can use the step out option, which is the keyboard shortcut Shift and F11. Another option for navigating through the code during a debugging session is, of course, to set a breakpoint and then press the play button, or the F5 key. In this case, the program will stop at the next encountered breakpoint during execution in the given debugger window. Thus, depending on how we want to check the execution of a specific scenario in our code, we have several options for this purpose, but of course, we always need to set a breakpoint. Moreover, breakpoints can also be optional. For example, instead of placing a regular breakpoint, we can add a condition to it by right-clicking on it, and then, in the condition option, create any condition based on which the execution of our program will be paused. So for example, I would like to stop this program only when the input value is equal to the value, let's say, hello. So now, with such a breakpoint, if I run the program with the debugger again, after entering a value into the console, let's say test, which is not the value hello. As we can see, the program has finished, and we were not stopped at that particular breakpoint. However, when I run the program with the debugger again, and this time provide the value hello, that is the value. which meets the breakpoint condition. As we can see after a moment, our debugger stopped exactly at that optional breakpoint. So even in this way, if we need to narrow down specific execution cases in our program, we can do this using optional breakpoints.